Welcome to this week's session. We are going to talk about solar architecture and modeling. So, learning objective first, we will explain the principles of solar architecture. Two, we explain solar modeling principles. Three, we'll relate to our local context. Four, we'll relate design concept to detailing to implementation, right? If you are talking about following the sun and designing in response to the sun. Okay, five will be the integration with the studio project. Okay, so for this semester, it is not a gradable component, right? But it's always nice, it's always good to consider the sun, how it moves, how it behaves as a starting point in every design. So here in Singapore, I think most of the time we are pretty much used to the sun being overhead, right? And most of the time you try to be under shade. Okay, and in this diagram itself is more of a temperate kind of setting where there is summer and there is winter. So you can see that actually the difference between summer solstice, right, and winter solstice is quite um, the angle at which it hits a building, in this case an object in a landscape, right, it hits a building actually is very different, right? The angle at which it hits. And the winter solstice is usually much lower and closer to the horizon. Okay, so therein lies an opportunity actually, because if when it's very cold, and I want as much sunlight as possible to enter the interior of my space, right, then there is an opportunity because I create an opening, then I have to consider how do I deal with the sunlight. Okay, so passive design means the usage of sun's energy without relying on mechanical means. Okay, so it relies on the natural heat transfer process of conduction, convection, and radiation to collect, to store, and to redistribute solar energy. Okay, so once again, this diagram itself, probably in the tropics, right, where the winter sun is very low. So where it is an object in the landscape, right, would be a thermal mass, right? So the outer skin itself is the first layer of thermal mass, and then you have the interior surfaces, which is another level of thermal mass. So in summer, right, when it's very hot, of course you will want as little sun as possible to enter the interior spaces. You want to exclude as much as possible, right? So one of the passive um, strategies that we have is a pitch roof, right, whereby the highest point, because hot air rises, so the highest point is actually not habitable, right? So hot air rises, collects there, and usually there's some outlet for the hot air to go out, right? But most of the summer sun is excluded in this case, right? So when winter comes, it's going to be very cold. Okay, so in that kind of situation, you would want as much sun as possible to penetrate deep into the space, and I want to collect it. I will want surfaces that's very absorbent, right, of this um, this energy from the sun, right? So it collects, it radiates out in the interior space. So it reduces the reliance on artificial means of warming the space, right, using radiators and stuff. Okay, so this is the basic principle um, behind. So I think in the local context, we are used to the sun being overhead. And locally, we have shop houses, right, as a kind of building typology that makes use of passive design very well. Okay, so later on, I think in the subsequent slides, we will share more about that. So we have to consider the site, right, the climate of the site, right, very broadly, whether you're near the equator or you're near the tropics. Okay, once again, the sun moves very differently, right? You have to consider the materials that you're going to use, right? Because you can collect, you can exclude, right? You can collect, and how fast do you want the heat to be distributed, to be radiated? Okay, because if you absorb, if you specify a material that absorbs the winter sun and it dissipates it very softly through the night, right? It actually it's very energy efficient. Okay, so it minimizes the use of artificial means of heating the space, right? So this the you realize that it's all centered around the movement of the sun. Okay, so rewind to last Sam's work, right? Notice that at the start of most civilizations, right, it is always centered. All the consideration, the physical forms, right, are mostly centered around the movement of the sun. Okay, so some elements that you think about, site planning, how are you going to collect it? How are you going to exclude it? Okay, so it's always a pros and cons. So it doesn't mean, I think in Singapore, um, you might be used to thinking like, oh, the sun, I want to exclude it because it's so hot. I want to be in aircon. I don't want to be under the sunlight. Let's look for shelter. Okay, so we are used to thinking about that, but there are many other locations, many other countries whereby actually at a certain point of time in the year, the sun is something that's so um so delicious. I will use the word delicious, which is why a lot of times, right? Let's say you go to the beach, you see a lot of foreigners, especially Eurasians. They would be like sun tanning, right? Where for us it's like, wow, it's crazy hot. What are you doing? You're still tanning in the sun, right? Because they enjoy it. Right? Imagine you come from a really cold country, right? For the sun to shine on your raw flesh, right? Your skin, right? What is a essential delight. Okay, so thermal mass, right? How do I do my 3D massing, right? If I want to exclude, how do I do my 3D massing if I want to collect and radiate, for example? Okay, so distribution. So after I collect, how do I want to distribute? How do I want to distribute it? Okay, so these are the things that actually has of architectural implications, and how do I control, right? The energy. How do I control the aesthetics, the solid and void relationship in relation to my design concept, and also all these things that you have to think about. Um, and you have to understand before you start the modeling. So, for example, if you are using Grasshopper, Ladybug, okay, so you might be using plugins or whatnot, right? But let's say if you go to the beginning, right, of the plugin itself, end of the day is about defining the relationships, like let's say for what is yellow and what is red, what is orange. Okay, so all you have to define all these values, right, before you can feed it, before you can do solar modeling. Okay, so it doesn't mean that once you have technology at your disposal, right, all these um, basic principles become not useful, lah, right? Is on the contrary that you need to know the basics before you know how to give value to the modeling. Okay, so in this kind of 3D diagram that you see, right, you notice that there is two lines, right? There is two sun. Okay, so one sun here and one sun here. Okay, so the sun moves its position throughout the year. Okay, so not sure whether you all realize it. You all can go and start to pay attention, right? Every morning, every evening, right? Just go and see. Pick a point of reference, right, in your house, or maybe in school, or maybe on the way to school, right? Observe, right? Pick a certain point of reference, then you'll know that it moves, and it moves by quite a bit, right? And but not as big spectrum as say a country in the tropics, right? But largely still overhead, but it moves. Okay, so for example, like between this and this, right? It might be a to and fro movement, right? And this is somewhere in the middle. So from here to move to here, it would take 6 months, right? And then 6 months for you to move back again. Okay, so that's how it moves. It looks like a face. Yeah. But anyway, there's apologies. There's some issue with the pointer. I don't know why um it will auto align itself to the right, but try to bear with it. Okay, so usually that's where you are sighted, the sight itself, when you feed in information on the sun path, right? The variance, the angle to the horizon, um, and where the morning, the angle, and the timing, and so on and so forth, right? You can see this kind of diagrams appearing. Okay, so it kind of visualizes things quite a bit. That actually the sun, although every morning it rises from the east, every evening it sets in the west, right? But it's all at different degrees throughout the year. Okay, so between a 6 year period, it goes to this point and then it starts coming back, and then it goes to this point and it starts coming back. Okay, so this diagram itself, more of a temperate kind of context, right? So you can see summer sun, most of it overhead, okay? And winter is closer to the horizon, right? So depending on the northern, whether you're in the northern hemisphere or you're in the southern hemisphere, right, the winter sun will be at different ends. Okay, so you can see that with this visual, right, you can then start to think about, um, you can test out your messing, okay, and observe how much heat is collected, right, how the shadows are cast, where the opening should be, is the density, is the collection, um, as per your intention, and are there any adjustment required, right? Those are the considerations you have to tweak along the way. Yeah, and that's actually the fun part about parametric modeling, where you can have like many different variants, right? And then you come back to it, and then you decide which actually serves your design intent best. Okay, so rewind a bit, go back to the basics. So in terms of heating, right? Um, how a space heat up, it can be via direct gain, where sunlight enters a space through glazing and openings, things like windows, right? Windows are a kind of glazing, right? And it's absorbed into the thermal mass of the floor or the wall, and it is then radiated back to the surrounding spaces when there is a difference in temperature. Okay, so for the energy to move, there must be a difference in temperature. Okay, so in this case, once again, you're collecting as much winter sun as possible. So what are you going to design? How are you going to design thermal mass? In this case, I know that for floor, I will probably want it to be rather heat absorbent, right? Because I want to collect the sun to cool the nighttime, right? And for the wall, there would be a difference between the wall at the opening side, right? Because I want to maximize the fenestration, the opening, right? Because I want as much sunlight to enter as possible. Whereas on the other side, right, thermal mass for the wall, I would also want it to be rather thick, right? Because I want it to be well insulated, right, from the cold outside. Okay, so but at the same time, I do have to consider ventilation or cooling as well. So here you can see there's some provision for vents for the air to move. Okay, so sunlight is one thing. Right here, you can see there's actually a vent that's catered for the flow of air through the space. Okay, so we'll talk about this again when we're talking about thermal comfort. Okay, movement of air is important for the overall sense of comfort in the space. So in terms of heating, there can be indirect gain as well. So this is where a thermal mass is placed between the sun and the space. Okay, so the heat is absorbed into the material and is then radiated back to the surrounding space when there's a difference in temperature. Okay, once again, it's a difference in temperature. So in this case, instead of using allowing the sunlight to penetrate the space, right? You use a thermal mass to let the sun heat it up. Okay, so the sunlight actually penetrated into the interior of the space already, right? And then this wall is usually on the inner side, right? And because of weatherproofing requirements, the glass is on the outside, and this material is at the inside, right? So the sun shines on it, and then the heat is radiated back to the surrounding spaces when there's a difference in temperature, right? So locally, I think the instance would be where you have a west-facing wall, right? I think not sure how many of you all actually stay in a room where there's a west-facing wall. Um, I used to stay in a room where there is a east-facing wall, right? And so east-facing wall, it captures the morning sun, right? And then the heat is radiated out during the hottest time, which is noon. Yeah, so it's not that ideal, right? Whereas for the western sun, um, it's also not that ideal, but not that bad because it captures the western sun and it radiates out in the evening, right? So um, during my childhood, the evenings are a bit cooler, right? But because we're in Singapore, there is no like need to make use of that radiation, right? But you would have guessed that if you are in a temperate country at night, right, it will be good to make use of that radiator temperature. Okay, so these are the things that you have to consider and think about. Okay, so heating, there's also isolated gain. Okay, so here you see in this diagram the use of a sun space. Okay, it has a floor of high thermal mass and a wall separating sun space from the living space. Okay, so this space is heated during the day and the heat is radiated back to the surrounding spaces when there is a difference in temperature. Okay, so usually they are used as a greenhouse. Yeah, this kind of sun space, right? Because there's a lot of glass, you're collecting the sun. It's like a mitigating space. Okay, so and then the plants need sunlight, right? So and they help to cool and mitigate the harsh difference in temperature as well, right? So these are usually seen as used as kind of greenhouse, mini greenhouse or mini planting area. Yep. So this isolated gain, whereby it's kind of captured in that space, and then you think about what you want to do with the heat that's collected. Okay, so it's you isolate it and then you think about how you want to control, how you want to distribute it. Okay, so cooling devices, shading devices, not cooling devices. Here we call it shading devices or sunshades. Okay, these are devices that provide protection to the glazed areas to reduce glare and solar heat gain. Okay, so because so far I think let's say if you are thinking about the design of your studio project, right? How it looks. Yeah. Have you all ever considered sun shading devices? Yeah. So probably not yet lah, right? So you will notice that um, around the island, actually HDB has incorporated quite extensive use of sun shading devices, and mostly they will use a solid ledge like that, yeah, in front of the windows. So this is a very important mechanism, right, to mitigate to protect the glazed areas, right, to reduce glare and solar heat gain, right. So it's very important, right. So imagine if you don't have that, right. That's why you will realize that okay, a lot of the condominiums, right, they are using full height glass, it's full height glass, and some of them actually don't have this kind of sun shading devices. So as much as they use very expensive and high spec low E glass, right? When the sun comes, it's still um, it gets rather hot. That is one thing, and there's a lot of glare coming into the space. Okay, so this kind of sun shading devices actually balances the need for it balances the need to have daylight, diffuse daylight, right, versus the need to exclude solar heat gain and reduce glare. Okay, so in this case, right, let's say you just compare. So in the first scenario, right, you can see that just okay, you're using a louver system. So this is a horizontal louver system. In this spacing, in this orientation, right, if you project the lines from the sun, right, you realize that there is a little bit of direct sunlight that will enter the space, that will hit the glazed areas, right? Whereas the rest are like diffuse away like that, right? So even the diffuse light, right, there is a certain quality that can light up the interior space, right? But probably not as deep into the space as, say, a direct sunlight, right? So in the second instance, right, same spacing, same profile, but just by tilting the angle, you notice that actually it cuts out the direct, the sun's rays, right, no longer touches the glazed areas directly. Yeah, it's all via reflection already, right? It's like that. Then this one will hit like that, like that. Yeah. So the effect of light that you get, right, is diffuse. Oh, so these two instances, same spacing, same profile, just different angle, different quality. Okay, so the third example, of course, if you are using a solid panel, right, that is in terms of cooling, in terms of cooling is the best. Okay, because it excludes the sun and then you don't see it. Exclude the sunlight, right, and then no direct sunlight actually hits the glazed areas, right? And there's no diffuse light hitting the glazed areas as well. Okay, so very good for cooling, but the trade-off is very dark, right? Because you don't have direct light, you don't have diffuse light. Okay, so it's a trade-off lah. So if you let's say if you visit the shop houses, right, or you visit the let's say the attap houses, the kampong houses, right, you realize that uh, it can get quite dark inside, right? But it feels very cooling. Yeah, so it's like it's always a balance. You choose one if you want a very cool space, right? Then probably you're gonna be a bit darker. Okay, vice versa. Okay, and screens, shading devices are something that we can use to mitigate to find the right balance in between, right? So that's the point of design. Okay, so how thermal mass works. So this is this is an example of the build out of a wall. Okay, so I think when you all draw a wall now, it's like two lines, right? Or two lines, or maybe a rectangle because you are doing 3D. Okay, but in actual fact, when you build out a wall, right, there are many ways you can construct it. Oh, so in this case, let's say um, they are designing for a 6 hour thermal lag. Okay, okay, thermal mass concept first. Okay, materials can be used as a passive cooling strategy, right, to absorb heat during the day and to dissipate it during the night. Okay, so in this case, you can see that, okay, there are two layers. There are two layers of wall. There's a masonry wall. There's a brick wall on the outside. Um, and which one is on the outside? Let's see. And the outside and the inside. Right. So two layers of wall, and in between, okay, you have this thing. Okay, you have the waterproofing that's painted. You have that. That should be a PVC-L plate, right? Then you have your heat insulation, rock wool insulation in between, and then you have the air gap cavity, right, for the air to move within the wall itself. Because you know that actually when the sunlight hits the wall, right, it warms up, right? So between the within the wall itself, right, you also need to cater for vents for it to heat up, to ventilate. So okay, hopefully I can do this. So as for example, this is the first wall, right? Then this is say the second wall in schematic section. Okay, I'm exaggerating a bit lah. So this rock wool itself, right, you'll be here. Okay, and this you have the waterproofing membrane, and then you have the PVC L channel like that. Okay, so um, okay, ugly sketch. Okay, so when the sunlight comes, hit it in this manner, right? The hot air will rise inside. Okay, it's coming back. So usually, okay, let's use in color. Yeah, so usually there will be ventilation opening that's provided right here and the top, right, to allow the hot air to dissipate. Okay, and you must have a weep hole at the bottom as well for the moisture to come out from the cavity within the wall. Okay, so in building, right, actually one of the scariest thing, right, is to trap the elements within the gaps, right? We don't want to trap air in any gap. Um, if you want to trap air, right, it has to be never mind. Okay, like we don't want to trap air in any gaps. We should create allowance for them to move in and out of that space. Okay, and the strongest element is actually water, right? So always designed to weatherproof, right? But also to consider in the worst case scenario where the water enters the space, right? How does it come out? Okay, because if you don't let it come out, right, it's going to cause a lot of destruction and damage. Okay, so yeah, rewind a bit. So in this instance, right, how thermal mass is used is that, for example, in the let's say between 6 a.m. 3 p.m., right, the user is using aircon. Sorry, pointer options, I'm using a pen. All right, so 6 hour thermal lag. Okay, between 3 p.m., 6 to 3, 6 a.m. to 3 p.m., right, using air condition, right? So the cold air the heat actually is getting collected, right, on the outside, right? And then it starts to build up um, in the inner layer of the wall, right, where you can see that there's actually cavities, the openings that are catered for within the masonry wall itself. Okay, and of course the structural parts of it will be infilled with concrete. But okay, so the hot air, right, okay, starts to build up, starts to be absorbed, right, at the inner wall after a certain period of time, because the first one that hits is actually the outside, right, and then there's the insulation, and then it builds up, right, eventually it builds up on the inside. Okay, so there's a radiating heat or cool, right, in the 6 hour cycle, let's say 3 p.m. to 9 p.m. Okay, this is where it radiates heat, right, and the other 6 hour cycle is where actually the interior conditioned air, right, comes into, heats up, cools down this wall. Okay, so that is, okay, I'm not sure whether you understand. Hopefully you do. But I find it a bit confusing. Okay, but the thing is that at a very basic level, you need to think about whether you are collecting the heat, right? If you are collecting the heat, how do you want to use the heat, Okay, are you using it to cool? What are you using it to cool? And what is the time frame that will be best to use it for? Okay, because there is a buildup of the heat, there's a dissipation of the heat. Okay, so you have to know this if you want to design for a very passively cool kind of space. So materials can be used as passive cooling to absorb heat during the day and dissipate it during the night. Okay, so throughout the day, the temperature actually there's a variance to the wall itself, right? Especially the east and west facing wall, and in our tropical context, the roof as well. Okay, and so there is the in this chart itself, you see the graph that charts the air temperature, typical thermal mass, and the optimized thermal mass. Okay, so that is you have to think about in every build up, right? Be it a wall or the roof, you have to think about insulation. You have to think about the storage of heat, right? You have to think about the movement of heat. How do you want to distribute it? Okay, so you have to consider that and decide, right, on the specification for the wall or the ceiling or the roof. Okay, so the basic principles. So for cooling, there is natural ventilation where windows and openings needs to be positioned in walls facing the prevailing breeze directions and on the opposite walls to create cross ventilation. Okay, so as mentioned, understanding is solar modeling, but it always comes together because it is about fenestration as well. So three diagrams you see here. On the left, you have single-sided ventilation. All right, actually not very effective. Okay, you have that. Sometimes when you are in a storeroom, a storeroom has a window. You open the window, but you feel like, oh, it's still very stuffy. I have to turn on the fan, right? In the absence of wind. So if you happen to be in a windy space, then good. The wind can come in and draw the air, ventilate the air inside the space, but very rarely. Okay, cross ventilation is where you have openings at the opposite sides of the wall, right? Situated at certain dimensions apart. Okay, for you to have crossband. Um, so BCA has a definition of what constitute crossband, right? This one we can talk about it at I think in the ACMB lecture. Okay, so crossband, I think cross ventilation used to be one of the questions that I think your DS tutor will ask you, like, oh, how do you factor in for cross ventilation? So I'm not sure whether it's still it is one of the basic things that you have to factor in the design of apartments, right? Very important actually. Okay, so for example, the position of your living room, okay, door not so much. Let's say in the position of your toilet doors, right, in relation to your bedroom doors, and then how deep your bedrooms are. Okay, so what is the spacing between them? Yeah, so these kind of parameters you have to play around and massage to achieve cross ventilation. Okay, so the third one, stack ventilation. Most of it is where a house comes into play, right? Where you have the roof, you can play around with the roof. So it takes into consideration the concept of hot air risers, cold air sinks, right? And so solar comes in tandem with ventilation, right? Because you are using solar to heat up the space, make it rise, and I create openings on the roof for it to escape, right? Thereby creating the positive and negative pressure, and then the air can move. Okay, so convective cooling, right? Another kind of cooling measures, where the cool night air is brought in from outside to displace the hot interior air. So alternatively, a high-level vent uses wind velocity to create a suction effect, allowing hot air to be drawn out of the interior spaces. Okay, so this is typically in the Arab countries where there is um, the night times tend to be a bit warm, right? And you want air movement you want air to be drawn into space and cool the space, right? So you want to create a suction effect by firstly tapping on the natural breeze, right? That's why you realize that the typology for um, the typology, the vernacular houses, buildings, right, in that part of the globe itself, right, they always have very high chimney for this kind of effect, right? Because once the air goes by, right, it actually creates a uh yeah, this would be a negative kind of pressure, right? So this is physics, right? Yeah, physics. So with the wind velocity actually creates a negative pressure zone. And what it means is that inside it becomes positive, and this will be positive if I do 2 plus lah. Okay, so then the air will move like that and move like that. This is by pressure difference, right? So by velocity is as well, it will just draw out the air in this way as well. The air is drawn on the leeway side. Okay, so with that, right, it's actually it's a chain effect, right? So negative it draws out, and it creates a negative kind of zone inside, right? Which in turn, negative positive is relative lah, right? So the negative zone is now created here, right? Then the positive zone becomes the lower part of the outside air, so it gets drawn in this way. Okay, so they because it's vernacular, so they're very smart lah. They know that the air coming in, right, is very sandy, it's very dusty. Yeah, so they actually allow for this kind of feature for the dust to collect, right? So it's dust, you collect the air, the wind from the outside, and then you dust it off, so that the entire space inside doesn't compromise. It's not compromised in terms of the quality. Like you don't end up with like sand over the sofa, so on and so forth. Right. So there's a specific position where they have catered for in the collection of dust. Okay. So the position, the geographical position, and understanding the context is very important. Right. So once again, shading devices provide protection to glazed areas to reduce glare and solar heat gain. I think I've talked about this, right? Yeah. It's a repeated slide. Okay. Okay, so case study examples. This is I think I used a few Kenyang project. So Solaris at One North Singapore, right? So in this case, typology is a green skyscraper. Okay. So keywords would be ecological, sustainable, bioclimatic, because it's climatic responsive, right? And the concept is that it's looking at the building as a living system, right? Not as an object itself, but something that is alive. Okay, so this is a view of the high performance shaded facade. Okay, so you can see as discussed, right, the use of shading devices, right, used very extensively in Kenyang's project in this case. I think you're all studying the National Library as well, right? So he has a very smart kind of louver system that allows you to use a diffuse natural daylight, right? Because if you have diffuse natural daylight and you have very extensive use of glass, right? What it means is that you reduce the reliance on artificial light, right? Which is a good thing, right? But at the same time, you want to minimize the solar gain. Okay, so it's a balance, and this is how Kenyang chooses to do it. Okay, so this is kind of like a gigantic shop house. I see it as like a gigantic shop house because you see. Okay, let's just run through the components first. You have roof gardens, you have continuous vertical landscaping, right? You have a natural ventilated day-lit atrium. You have the solar shaft, right, and internal planted terraces. There's a climatic responsive solar shaded facade, which we were talking about just now, just purely functional. Sky terraces, and the concept of a veranda way, a semi-enclosed tropical walkway, right? Nowadays I try to avoid the word tropical, right? And yeah, I understand. Yes, we are tropics, but remember we just to rewind a bit to the last semester where we were talking about colonialism, right? Actually, this okay, I just digress a bit. So actually, this tropical term, right, has a kind of colonial implication. Yeah, because back then they were trying to segregate, they were trying to categorize the sphere of influence lah, between the territories that they control. So it's like, oh, we have the tropical areas, then we have the subtropical areas under our sphere of control, right? That's kind of like the beginning of the term tropical. Okay, so um, so I would tend to avoid using this word and look for other alternatives like maybe sustainable, biophilic, so on and so forth, right? In order to create a more universal kind of approach. Okay, so okay, sorry to digress. The last bit is EcoCell rainwater harvesting. Okay, so if you are talking about solar, um, I think is one thing is the use of the atrium, right? You notice that within the atrium space, right, it uses very reflective surfaces, right? So the glass surfaces can bounce off the light into the interior space, right? So the interior space itself, let's say this is the entire plate, right? You can see that actually the diffuse light is very good at this corner and very good at this corner, and it kind of dwindles towards the middle, right? It dwindles towards the middle. Right, so the middle will have to rely on this portion. We have to rely on artificial lighting already, right? So that's why there's this consideration as well about the depth of space that we have to consider. So if you contrast this versus say this one, let's say this plate now, you can see that okay, it has diffuse daylight, and it also has a diffuse daylight on the other side. So the reliance on artificial light is actually very low in this series of space. So you can see that within this massing itself, right, very different explorations of different ways office spaces can be done now. Okay, so you can see that without this diagonal light shaft, right, that he has used to cut through the space up, the actually the floor plate is quite deep lah. Yeah, so this is a kind of this kind of way that you can respond to the sun, right, and use this kind of um, components to by carving this hole and using reflective surface, right, I bring in natural daylight into the interior spaces. Okay, so one of the architectural strategies. Okay, then of course when you're the sun, when you want to mitigate the sun, you typically use screens, right? If you want to reflect it, you'll use reflective surfaces. If you want to mitigate the sun, it's very good to use very lush greenery as well, right? Because greenery also adds a touch of biophilic, um, a very holistic feel to that space. Okay, so it mitigates any value adds. Okay, so and then okay, let's say you bring in greenery to the picture, then how do we irrigate it? Right, that's why you have the EcoCell and rainwater harvesting provision that's here. You have the water tank and then the piping systems. Right? So if you look at this, right, yeah, it's actually like a giant shop house whereby you have this veranda space, okay, which is pretty consistent with say the void deck for HDBs. All right. So because with that, if you allow the sun to enter the atrium, you heat it up, right? The hot air will rise. All right. So it creates this movement of air by drawing in the air from the veranda way. Right. That's why for National Library you'll find that the atrium space, right, is so generous, right, and it's always so windy. Okay, another of Kenyon's project, this in Selangor, Malaysia. Once again, the typology is a green skyscraper. Actually, in his vision, is much more. It looks much more greener. Green in the sense that, as in there are more plants, right? But this building itself is very green in a green mark kind of way, right? Because of the energy efficiency and so on and so forth. Okay, so once again, it's bioclimatic, responsive to climate, and it looks at the building as a living system itself. Okay, so this was done in the early 1990s. I think completed in 1992. Right, so I think that was 30 over years ago. Okay, so Ken Yang is always a forward thinker lah. Okay, so the concept is quite simple. He has a cylindrical shape, right? So that's the architectural messing as a starting point, right? So you can see that in his earlier sketches, he considers okay, where the rain is from, and how do I want to collect the rain? Where the wind comes, right? Which direction the wind is coming, right? And how do I manage it? How do I bring it into the interior spaces to ventilate it? Okay, so there's a building mass of the cylinder, and there is this the idea of the what's the word? Maybe we just use greenery, right? So in this case, there is another spiral that moves in a separate way, right? It spirals up, right? That's a plant. So you notice that actually he has these two decks here, right? That's like where the plant actually the ground meets the building, right? And then that greenery is supposed to spiral through, right, to the top. And the rainwater is supposed to make use of this channel itself, but it spirals down. So it's a natural form of irrigation, and as well as drainage. Okay, so for architectural for the program, you can see that it's a cylinder. Okay, so you have, let's see, interstitial spaces, right, to be filled up for future extension, right? So he's thinking about future proving as well, right? Yeah, this is one thing that a lot of junior designers actually are kind of blind to, right? And we have to foresee down the road what the users will do. Sometimes we even have to foresee like 30 years down the road if they're going to renovate the space again, what's going to happen, right? That is I find actually a good value add to for the client, right? Because that is something that the architect can foresee with his or her skill, right? So okay, terraces and then the recessed wall on the can be curtain wall. Okay, so in this case, you have the best of both worlds. You have the because around this building is very nice greenery, lah, right? So you want curtain wall, but at the same time, you want to be conscious. You don't want to have so much solar glare, and you don't want to have so much solar heat gain into the space. Okay, so how does he deal with it? Okay, so in terms of sighting, this is very important, right? The north arrow, right? Yeah, actually, this is the starting point. With this, right, you can read the intent much better. So here you can see that okay, this is the east, right? It's black. Anyway, okay, this is the west. This is the east. You notice how he groups the facilities around it. In the east, right, that's where the planting starts, right? And then there's a slope up to the roof, right? At the west side is where he provides most of the parking spaces, right? So it's kind of nice because if you come to this building and you park it there, for most of the time throughout the morning, right? Actually, your car, because it's surface parking lot, your car actually benefits from the shading due to the shape of the building, the form of the building. Okay, then at the towards the evening, right, is vice versa. So the spaces here are shaded by the giant atrium space, which is a big volume over here, right? So on and so forth. So let's take a look at the upper stories. At the first floor, you can see that okay, the atrium, the auditorium space is here. Okay, so this is the west, right? This is a big volume there, right? Takes care of the on the western sun, and on the eastern side, you have the service core, you have staircase, lift core, lift lobby, right? Two more lift cores, and then the stair core, and then you have the toilets here. Okay, so this is how he groups the spaces, and this is a mezzanine floor. Okay, so mezzanine floor meaning this is a void space, void space, void space, right? Double volume, triple volume, right? So in the evening, actually it helps a lot, right? By it's like a giant sunshade, right? For the evening sun, right? So it doesn't mean that the evening sun is not good and is always to be excluded, right? You can if you can capture it, you can diffuse it. It's actually something very nice. You can create very nice lighting effect for the atrium space, right? So that's where like if you have events at night, right, is a actually a very nice experience. Okay, so this is how it looks. The examples, photographs. Okay, so this is on the left. You see the northwest. Okay, on the right you see the southwest. Okay, northwest. Yep. So the northwest. This would be north. Yeah. So this is the west. There's the east. This is the west. Yep. So actually the west would be somewhere here. This would be around south. Yep. So you can see the in terms of the sun shading, right, devices, there is a few standard components. You have this solid panels, right? You have this kind of linear panels, right? And then you have the curtain wall right inside. Okay, so you can see that how he responds to the west, right, versus say the south, right? The amount of transparency, let's say in this phase, right, versus this phase, you can see the strategy is very different. On a south is relatively transparent, and the curtain wall is located close to the perimeter, right? Whereas at the west face, right, he uses these kind of solid ribbons, right, to take care, right, the first contact with the from the western, the evening sun, and then for curtain wall, he still has that, but he recesses them much deeper into the space, and he uses the terrace, right, as a mitigation device. Okay, so these are some of the architectural games that is played. Okay, so this entrance and the mezzanine deck. Okay, west would be this space. Yeah. So once again, it doesn't mean that the west sun should be excluded at all times, right? If you're able to capture it, it can have a very nice interface with your architecture, right? You can make it sculptural. Okay, there are step balconies. So as seen just now, right, you have curtain walls here, right? But the curtain walls, there is a very deep, is recessed quite deeply on the inside, right? So you have the benefit of a diffused daylight. You have the benefit of views to the outside, right? At the same time, there's reduction in in the solar heat gain. Yeah, which makes the space very comfortable. And because this kind of terrace itself, right, is a very good kind of multi-purpose. Nowadays we call it a breakout space, right, whereby you can have events, or you can come out. It can even be a gathering space. It can be let's say a eating space. It's very nice for that, right? So image on the right, where the sun roof is, right, you can see that there is actually a skeleton system designed at the rooftop. Okay, where the pool is. Okay, so you also want the sun, but you want to control it. Yeah, and bear in mind that this building was done in 1992, right? Back in 1992, actually solar panels is still very expensive. Yeah, so doesn't mean that something is very expensive. You cannot do it, right? Sometimes it's about timing. Yeah, so in this case, Kenyang has provided the skeleton for it, right? So that next time when that technology becomes more affordable, like 20, 30 years down the road, like now, right? You finally achieves the economy of scale to be affordable, right? Then maybe in a renovation project, the developer can install the solar panels. Okay, so once again, it's thinking future proofing for the clients. Okay, other photographs showing the view from the entrance, right? So once again, it's recess space. This is west facing. Recess space use of curtain walls, right? So it can have a very nice lighting effect. You can enjoy the view of the setting sun, right? And be spared from the heat gain. Okay, the reception lobby you see at the bottom, right? You notice that it uses a very reflective surface for the floor, right? So this is one of the tactics that you can use, one of the techniques that you can use, right? By using reflective surfaces to bounce off diffuse daylight deeper into the space, okay? But you have to be careful because we also don't want it to be so reflective that it compromises the privacy of the user of the space, lah, right? But that is one of the common tactics that we use, right? Alternatively, you can use it on the walls, right? So let the wall do the bouncing off, right? But be mindful, as mentioned, about modesty. Be mindful about glare also. Yep. So on the right, you see the mezzanine deck, right? And you see the big auditorium space, right? And auditorium, because of the nature of the space, it has to be very well insulated in terms of acoustics, right? So you can't have openings, right? Yeah, so you have to depend on artificial means to ventilate the space, cool the space as well. Okay, southwest elevation, um, and the section, right? So you can see the difference once again in how it's treated, right? Where you have the east, right? So the east sun, how good it is for the plants, right? Which is like his in one of his sketches, right? You see sketches a spiral. So this is a starting point, right? So it builds up and then it uses this terrace to spiral around the building itself, right, to the rooftop. Okay, so architectural form and nature having a coming together with symbiosis. Okay, and remember the difference in treatment between the south-facing components, portion of the curtain wall, and the west-facing, right? So you have sun shading devices, trellises, right? And then you have recessed terraces. Okay, so some example of architectural strategies that you can use. Okay, east elevation. Okay, so you can see the generous planting that's here, right, allows it to spiral up, right, and this is where it enters the building. Okay, so you can see once again, revisiting the sunshades, right, you have one giant ribbon and three smaller ribbons, right? If you, for a bit of variety in the way that you treat your facade design, the sun shading devices. So all these, when it comes together, right, is a play of pattern as well. So it breaks up because at the starting point is a cylinder, right? So these are some of the things you can use to break up the geometry and the monotony of the surfaces. Okay, so in this case, you can see, okay, 60 degrees, this one should be around 50, right? So the amount of daylight that can enter the space is controlled. Okay, and just a small detail here, like this pelmet, it has to come during this period. Yeah, this pelmet usually is for the roller blinds. Usually they have a additional layer of roller blinds coming down, right? Um, you, yeah, for those who are doing National Library, you can see that, yeah, and then you stay inside the space, you can see the blinds adjusting themselves throughout different times of the day. Okay, I think the roof plan You all can research if you're interested. Okay, let's try to accelerate. Yeah, so sun path diagram. Okay, this is in the 80s, 90s, right? This is we don't have the benefit of technologies we have nowadays. So this is the typical way that we do the sun path. So you can see from east to west, right? East, west, north, south. The degree from the horizontal, and then at um, that time of the year, the specific month, right? The specific hour of the day where the sun will be. Okay, so for example, like yeah, so for example, like 6 a.m. Let's say 6 a.m. in January. Okay, north is there, right? East is here. Okay, lah. Let's say between 6 months cycle. So this will be Jan. Ah, come on. Okay, just will highlight that. Okay, so this will be where the sun is at 6, say in January and in December, right? And this would be 6 in mid-year, say in June to July, right? Because the sun will travel from here, will travel here and then back, and then here and then back, right? So this cycle, yeah. So this cycle itself, right, coming here and back. Yeah, this cycle will be 1 year. Yeah, and then this will be your mid-year. Oh, they're doing it even for the highlighter. Yep. So I think you get the idea. So for January at 6 a.m., this will be here at noontime, right overhead, right? 17 at 6 p.m., you'll be in this position, right? Same goes, say for the middle of the year in during June, right? 6 a.m. is here, 12 noon is here, and 6 p.m. is here, right? So I think we are used to, let's say noon, the sun is overhead, right? But it's overhead at different positions throughout the year. Okay, so for your interest, you all can go and observe, but please don't look at the sun directly, right? Always use a device to mitigate the rays. Okay, but just paying, you can also look at shadows to see how the sun moves. Okay, so for thermal analysis, some of the parameters, right, that we have to give data to, right, it can be weather, locations, with the comfort range, the calendar year, right, the internal gains, the artificial lighting that you have provided, right, because you can tweak it, let's say the amount of lux you have designed for, you can tweak it in relation to what the external daylight is giving you, the value the external daylight is giving you, right? Equipment gains, chimney gains, ventilation, so on and so forth. So equipment gains meaning like let's say in an air conditioned space, right? The space is air conditioned, but the fan coil unit, it is a machine, right? So if you on it, right, the machine will also give out heat, right? So the heat, the cold air that is thrown out to cool down the space, right, must cool the machine itself as well, right? In addition to the overall space around it, right? So equipment gains like your projector screens in classroom, your laptops, right? All these, there must be certain value, there must be certain assumptions given to it, right? In order to have a more accurate study. Okay, so another example, this building in Australia. So you can see that actually the way that they treat light, the sun, very different. So once again, they also have the pitched roof, and they are also trying to exclude the they're trying to exclude the summer sun, right? So actually this you can see that actually this portion they actually this is the highest point of the pitch lah. So there's added additional insulation to that, right? But you notice that there is a particular view, okay, that they want, let's say this view, Right, very nice. I want that particular view, and I don't have an issue if I have that view. Whereas for this phase, I want the view, I want the sunlight, but at the same time, I want to control it. Okay, so these are some of the you can see that actually these are roller blinds that you can pull all the way, and then there are louvers. So they always use um, they can use multiple layers of controlling devices. So at some time it can be opaque, sometimes translucent, right? And sometimes if you want the fresh air, you might open up the glass and just use louvers. Yeah. So they have the way they design walls, right? Very interesting. Is a composite system, right? So another thing to note is also notice the type of materials they use for the interior, right? So it's timber, it's veneer, timber flooring, polish finish, right? So it's a timber or veneer dining table, polish as well, right? So the whatever fitment you have inside, right, it collects, it allows the sunlight to bounce off it. Okay, so the interior, um, for sure is well shaded, right? But it also mitigates the dullness, right, by having this kind of reflective quality in the selection of interior fitments and furnishing. Okay, so this is how this is a sketch by Glenn Murcutt. So he's famous for he's Australian, so very famous for understanding and being very sensitive to the elements, right? And of course, the sun is one of them, right? So this you can see that in this it's a very simple building, but also very complex because in the understanding of how the sun moves. Okay, so he knows for sure. Let's say in 21st of June, September 4th, respective quarters, and 21st of December, at what particular angle the sun is hitting at these particular locations, right? So with that, he's actually able to establish the width of the roof eave, right? And the precision of that tip, right, actually ties in with the precision that he knows the sun path. Okay, so he's able to control for sure, right? You can see that with this line itself, okay, June 21st, right? I know that it's going to hit right up to the edge of the inner space, right? September 4th, right, is going to just enter. It's going to cover the entire veranda space, but it doesn't hit the interior space yet, right? Whereas for 12th of December, it is excluded. Okay, so with that, the modules are established, and then he considers the views to the outside, right? Your city buildings, to clear tallest, 2.5 lowest, so on and so forth. So where is the view to the city, to nature, right? So do I want that view? Can I afford it, right? Because if I have a view, but I don't want the sunlight, then what do I do about it? You know, so there's architectural implications. And here you can see also there's this specification glazed sliding door, right? Four slates, right? And north, south, north, east, west, insect mesh, or larger aperture and slates to keep out the birds. Yep. So yeah, it's a very transparent building. It's a very open building, right? In a very nice part of nature, right? And you will realize it that for the benefit of the site, right, you have to deal with insects, you have to deal with birds, and probably any other creatures as well, right? So how do you deal with it in a aesthetically pleasing manner? Okay, that's why Mecca is so celebrated. So once again, sun path, right, for that particular part, right, some of the sketches, you can see that it's somewhat in the valley, right, but not at the lowest point. So how is it going to affect the wind flow? How is it going to affect the sun path? And yep, sun path diagram. You can see that, okay, is leaning more towards the northern side. So actually for the southern side, right, I can open it up. I can use clear glass all the way. I don't even need to use sunshades. It's okay. Okay. Okay, so once again, knowing for sure at which time of the year, which angle the sun is hitting, right, lets you define the edge of the building. Okay, so anyway, this is another markets project. So just very simple, two rectangular volumes, a juxtaposition, right, allows him to have a cross ventilation into all the spaces. Okay, you notice that this is a bit like the Farnsworth house, right? Yeah, but reimagine. So this veranda space, right? You have the living room, dining room, which is the view. Sorry. And then you have I'll try not to click. You have the kitchen area, you have the back of house, and you have the bedroom. Okay. And then you have the guest rooms and communal living areas and the veranda space. And then you have the passageway right in the middle. Okay. So the way that cross ventilation is catered for, you notice that, okay, let's say for the toilet areas, right? It doesn't allow cross ventilation and then the air to be brought into the bedroom. Yeah, it's actually brought into an open space, a veranda space. Okay, so whereas in this case, okay, is living dining to living dining, so not much of an issue to have cross ventilation. Yep. So this one as well, veranda space to the bedrooms, and you have the toilets in the middle, right? It's ventilated directly to the outside. Okay, so in terms of consideration of cross ventilation, you also have to consider the type of functions of the particular space. Okay, example of sun path analysis for that building, right? Somehow the resolution gets worse with every use. I don't know why, right? But I think you get the idea. As use colors lah. So in this case, because it's sun, so usually we use the warmer colors, like the spectrum of light yellow to dark yellow, let's say the orange to red as well. Okay, so modeling of the interior space. Okay, some things consider orientation, daylight factor, illuminance assessment, so on and so forth. So it allows you the illuminance assessment gives a quantity, right? So it's not just without the assessment, right? You just look at the rendered image and then you say, oh, this is well lit and whatnot. So the illuminance assessment is important because it gives a specific value. Like for example, you know that or the red lines are between like 850 lux onwards, right? Whereas the green lines, actually, if you trace it back, it's 250 lux, 200 lux, which is sufficient, right? Right, but some they might prefer to go up to 300. So what do you do about it? And actually, for 150 and 50 for functional space, actually not that sufficient, right? But I think maybe in a bedroom setting, I don't know. It's up to the designer to specify it. Okay, so these are important data to have. Okay, so you have the zones and you have the DF scale. So you can see that from this scale itself, color has a temperature, right? So, for example, you don't use um, blue, right? You don't use blue to represent the hottest part of the room, right? It's you have to be in line with the temperature of the color. So yeah, I think this is generally not an issue, lah, right? Yep. So some examples of how it can be done, right? Many different ways. You can zone it out and then conduct a study of each individual zones. Okay, so just some examples. Apologies for the low resolution for that. I don't know what happened. Okay, so this is next we are talking about solar panels, right? So that system of how do we collect, how do we harness solar energy from the sun. So it's not just I install solar panel on the roof and that's it, right? In this diagram itself, you can see that okay, the entire process itself, you all can read it, right? But just focus on the physical components. First, you need the solar panels, right? I need an inverter, I need a breaker, and I need a battery. Okay. And from the breaker box itself, right, there are two paths to take. Am I feeding it to battery for storage? Am I feeding it for the building to use? Or if in the event of excess, right, am I feeding it to the grid? Right. So these are some of the decisions that the system has to make. Okay. So it's not just providing panels. So if you want to provide panels, right, you must have the space for the inverter, breaker box, battery, and how it's routed to the consumer, how it's routed to be connected to the grid. Okay, so this has all these has planning implications for your site. Okay, so light from the sun contains photons. So some of these photons hit solar modules, which consists of many connected solar cells, right? So hitting the top layer causes electron to flow through the bottom layer. So this movement of electrons generates DC current, right, which flows to inverter. So inverters convert this DC to AC, and then AC is then used to power the building, reducing its electricity bills and carbon emission, right? And this solar electricity can also be charged into a storage system, right? Or it can be fed back to the grid to for other buildings to use. Okay, so actually this is very common in Europe. Okay, and there is an angle, there is an angle, optimal angle to place solar panels. Okay, you can't just do it like because you have to consider if I install this surface, right? I mean, you notice that most of the panels for us is horizontal, right? For obvious reasons, lah, right? But there is usually a tilt because you have to consider maintenance, right? If you don't maintain it regularly, right, you will collect dust, and if you collect dust, the efficiency goes down. It's almost like every day is a cloudy sky, but the clouds is made out of dust. Okay, and then there's angle, the most optimal angle, usually between like 10 to 15 degrees, right, where you can capture the greatest amount of sunlight throughout the day. Okay, so this one we're going to talk about it just for your awareness, because I don't think you are going into that level of detail, right? Probably you're gonna, as long as you don't give me um, like vertical solar panels, right? Vertical solar panels in our context definitely is a waste of money, lah. Yeah. So anything that's horizontal is rather safe for our context. Okay, so solar PV cells so far is the most promising renewable energy source for our country. And recently in the news, right, we are, I think I talked about this last week, right? Yeah, so we have in collaboration with Australia and our surrounding neighbors as well. So we have wind turbines, we have solar farms, right? And then we have subsea cables bringing all this energy back, right? For the case of Singapore, it is unlikely that we will be able to be self-sufficient purely using solar, right? But at least it can mitigate the energy consumption. Okay, so PV cells has little to emission, very clean, and contributes to energy security. Yep. So yeah, that is all the good points about it, right? So um, the another point of consideration is also, for example, if we have floating solar farms like what you have seen here, what you see here, right? The question to consider for us as designers is actually what is the ecological impact? Yeah, because in the absence of this kind of floating farms, right, actually the sunlight goes directly into the water, right? And it penetrates deep into the water. So it allows plankton to grow, it allows seaweeds to grow, right? So that is the basic level of the food chain, right? So if you're excluding this sunlight, what is it going to happen? What's going to happen to the marine ecosystem, right? There's a question mark, right? So then another question mark is you notice the greenery at the side, right? So um, a lot of times we have birds, they are migrating from place to place, and then they do stop over, right? So when they stop over at this kind of forested areas and sometimes all around the island, it actually plays a very important part in the diversity of the ecosystem. You know, they might bring seeds, they might bring other things, yeah, and drop it off here and there, right? So bearing in mind that solar panels are actually reflective. So another question mark is that does it change the flight path of the migratory birds, right? Do they choose not to come here anymore, right? And how is it going to change the biodiversity? Okay, so this one is just speculation, it's just questioning. Nobody has an answer to that. If someone wants to have an answer, is probably going to study it by over 10 or 20 years, right? And I believe someone is actually doing it, right, in the Higher Institute of Learning. So, yeah, so that are some of the things that designers get to think about or get to worry about. Yeah. So, Singapore solar PV market, right? You can see that as of 2019, right, 3Q, there's a there's accelerating cumulative PV installed, right? So rewind it to 1992 when Ken Young did that building in Selangor, right? Um, Photovoltaic cells was like so expensive, you know, so expensive because end of the day, there must be a return on investment, ROI, right? It must pay for itself within 5 to 6 years. Then I must have energy saving for it to justify my investment, right? So fast forward to today, actually it has gained such economy of scale that it's become something that's feasible. Yeah. So in terms of planning, right, we need to have a longer time frame in terms of when you're dealing with architecture. Okay, so this is not PV cells, but just to share some of the other interesting products, devices that can utilize the sun, right? Not in terms of the energy. In this case, is for the light. Okay, so this is a sun pipe, or in if it's long enough, we call it the sun tunnels. Yeah, so it is very fascinating because basically it's an opening, it's a waterproof opening at the top, right? So it allows the sunlight to come inside. And then within that pipe itself, right, the tunnel is a mirror, right? It's all glossy surfaces, very reflective surfaces. So it allows the sunlight to bounce, 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 right? And what you see at the interior spaces, right, is the same as LED light. Yeah. Last time it used to be quite obvious, lah. Like it's I don't know how to describe it. Yeah, but it can be nowadays. It can look like just another LED light. Yeah, and it's very interesting because utilizing a mirror, the principle of reflection, right? Actually, if you have one source that captures the daylight and you bounce it off, you can you can light up several light concurrently. Yeah, until the efficiency drops. So at the moment, right, I think it's for around 9 to 12 meters. I think we are quite safe. Yeah, 3M has this product actually that sun pipe tunnel. Okay, so you have one source, you let it bounce and reflect it, right? So in this case, right, the entire corridor can be lit just by one source at the rooftop. Yeah, quite interesting. Yeah, and Also, I mean, if the owner wants to, he doesn't want to bounce it off too long, he doesn't want to have too long kind of tunnel, they can also have individual sun pipes, so both works. Just a very interesting concept. So I think in consideration of the technological advancements, the systems, the products we have at our disposal, right? We have to rethink the integration of products into architecture. Yeah, we can't really think of architecture as just the discipline of building, or rather building in a very traditional way, right? Of course, the principles are good to have. So things like legibility, materials, material planes, form follows the sun, things like shading, messing, things like disguise, even, right? These are just throwing out points that, yeah, you can think about when you are considering bringing in the sun into your design, right? Because just now we're just looking at arrows, knowing it, where it comes, and so on and so forth. But you can see that even for a very small architecture, it can be very rich. In the examples of Glen Market, yeah, so these are the bigger examples. You can see the use of photovoltaic cells at the top, at the rooftop, and the concept of messing, right, is a transparent volume, right, including the roof plane, and the roof plane is shaded by PV cells, right, and then the interior space, because it's triple volume, there's the usables, the functions is another volume within that envelope itself. Right, so it can change the way, the texture, the pattern of the facade, again, right? So this is obviously in a tropical country, right? Because as I mentioned, right, in Singapore, if you want to use PV, most of the time you have to use it close to horizontal. Okay, so you can see, I'm not sure whether you all notice, there is a interesting pattern for the facade. And you notice that some of them is transparent, some of them not. Oh, so actually this, for example, you can use this. This is a PV cell because PV at this angle it collects the sun, right? And then this is glass. I just use window lah, W. Yeah, so you have the window, and then because it's deeper at the top, right, compared to the bottom, so you have that shaded effect for the light, for the sunlight, right? So it collects the sunlight, you shade it, and then you have the view. And when these two things come together, you end up with a pattern for your facade. Okay, so one of the example of the possibilities that um, adopting PV technology can create, right? You can take a more organic approach, right? Like something that really blends in. Not so much just example, but the roof form itself, right? Where you choose to bring in the daylight, right? Here you can see even where the daylight penetrates the space, right? It's kind of random. They try to be as random as possible, right? Although it's still organized by the hexagon, right? And then this walkway itself, yeah, there's more generous daylight. Yep. So this is here in Singapore. This project, if I don't remember incorrectly, should be by DP. So interpretation of house, apartment, right, in the middle of two. You can see the typology, right, of this order, right, this, and then this order is maintained. Okay, so this neighbor, okay, let's see whether he has the same. Yeah. So this still takes on the same kind of order, follows through the rhythm, right? But then it starts to distinguish itself by this high double volume atrium space that is recessed from the front, right? And the use of greenery, the use of natural materials, and the color palette and the use of photovoltaic cells in this case is being used as kind of design um, component as well. Okay. Yep. So once again, language. So this is language, a frame system to hold up the PV at the rooftop, photovoltaic cells at the rooftop, and how do I treat the volumes that's underneath this large overhanging roof, right? So what kind of language are we after? And of course, here is where the panels itself um, are more. Actually, it's not mobile. It looks mobile, but actually it's not that mobile, right? But the effort at creating a variety is there, right? Just to explore the potentials for um, the incorporation of PV cells into a housing unit, right? And the ability to monitor the performance throughout the year for each kind of incline, right? And or to allow a more comprehensive harvesting of the sun's energy throughout the year. Okay, so another example of this is a bit like Rojak, the frame roof panel language, right? Coupled with a more organic approach, right? And trying to blend in with the language of the hill, right? Yep. So once again, orientation in this case, um, angle of the PV cells, and here there's a mirror finish on that side. Um, the reflective surface, right? So where should that be? And that achieves a different kind of transparency, a different kind of reflectivity at night versus the day. So actually, the relationship of solid and void changes, right? There's a difference between morning, daytime, and nighttime in terms of the transparency and the volume of the building. Okay, so this is a more okay, should not judge, but a more okay, if I don't judge, I don't know the right term to use. But you can see that in terms of the massing is more massive, right? And the extensive use of PV cell at the rooftop. Okay, so this is just another nice little house in the suburbs, right? So what is the point of interest in this photo? Tesla car, yeah, Tesla charger, right? Yeah, but actually what I want to show you is the roof tiles because the roof tiles are a product from Tesla also, and it's PV. Oops, not this one. Yeah, the roof tiles, right? These black clay tile look-alike is actually photovoltaic cells. So Tesla has developed um, this kind of product whereby it mimics the look of a classical suburb house, but it has that technology of harvesting the energy of the sun, right? So it's a win-win kind of situation. Quite a number of wins actually. You have that classic look. You exclude the sun, you exclude the heat, but you tap its energy, right? So this is example of Tesla branching out into building components. Yeah, and then this one, this is well, I think this is Japanese technology, right? How thin can they go, right? PV cell. So it need not be a panel form. It can even be a film, right? So when you push PV cells to this layer of thinness, right, there is also a lot of possibilities, right? Now, maybe my umbrellas can be PV, right? Or the clothes that I wear, right? Maybe it affects fashion design as well, right? Maybe a part of what my raincoat, is actually made of PV cells, and I can put just brainstorming. I can put a phone and then it charges my um, phone or what, and suddenly you see so many people like it's daytime, noontime, and then so many people wanting to take a walk in the sun under the sun to charge their phone. whatever. Yep. Um, Nowadays we have looks like a piece of glass, transparent glass, right? But this is a PP cell. Yeah. So the point is that we're always innovating, coming up with new products, right? And very interesting times lah. And for us architects, we get this kind of so many toys that you can play around, mix and match, and play with, right? So nice time to be in. Okay, so thank you. I think this wraps up my sharing for this week. So thank you for your time and attention. Right? Any questions, you can just email to me. Okay, see you next week. Bye bye.